So the first example is finding the circumcenter. Remember, if we look back, the circumcenter of a triangle is the point of concurrency of the perpendicular bisectors. So, because x has the coordinates, and let's look, x is at 1, 1. Y has the coordinates 1, 7. XY lies on the vertical line, x equals 1. So all it's saying is that side xy is on the line x equals 1. The perpendicular bisector of xy is horizontal to that line, so we need to find the point that's halfway up that line. So we're worried about the y value. Since the x values match, we put 1. Then we're going to add the two y values and divide that by 2. So it's 1 plus 7 divided by 2, which would be 1, 4. So that'd be this point right here. That's where our line is going to, that point is going to be on our line. So the equation of the perpendicular bisector is y equals 4. So I'm just going to draw that line in here. Y equals 4. Okay, then x, the coordinates are still 1, 1. Z has the coordinates 5, 1. So since they both are on, the y values match, they're on the horizontal line y equals 1. The perpendicular bisector of xz is the vertical line that passes through, so this time the y values match, and we're going to find the average of the x values. So 5 plus 1 over 2. And if we solve that, 5 plus 1 is 6, divided by 2 would be 3, 1. So the perpendicular bisector of xz is on the line x equals 3. So if I go to 3, I'm going to draw a line through x equals 3. So, and we drew these, so y equals 4 and x equals 3 were our two lines. They intersect at a point right here, and that would be the point 3, 4. And that point is the center of the circle that is circumscribed in triangle XYZ. So this is the center of the circle and the circumcenter because it's circumscribed. Okay. So let's look at example 2. Example 2 says that city planners want to locate a fountain equidistant from the 3 straight roads that enclose the park. Explain how you can find the location. Okay, so the roads form a triangle, which they drew for you. Theorem 5.7 states that the bisectors of the angles are concurrent at a point equidistant from the sides. So that's just, we copied that straight from the beginning where we talked about this theorem. The city planners should find the point of concurrency of the bisectors of the angles of the triangle formed by the 3 roads and locate the fountain there, because then it'd be equidistant from all 3 roads. I'm just going to draw it in here so we can kind of remember what it looks like. If this bisects this angle, draw another one. This one bisects this angle, and then if I split this angle in half, so then we would put the fountain in the middle where those 3 lines meet, is the idea that they're pointing out. Okay, then example 3. Find the lengths of the medians. M is the centroid. Okay, important to remember. Of triangle WM equals 16. Find WX. So the centroid is the point of concurrency of the medians of a triangle. And remember, medians go from a vertex and are to the midpoint of the opposite side. The medians of a triangle are concurrent at a point that is 2/3 the distance from each vertex to the midpoint of the opposite side. This is theorem 5.8. Okay, so if you wanted to check, you could go back. Because M is the centroid, of triangle WM, this segment here is 2/3 of WX. So if we set that up, 2/3 WX, that's theorem 5.8. We got that from up here. So we know WM is 16, so we're going to substitute 16 for WM. Then if we want to solve this, you have to multiply by the reciprocal, which would be 3/2. 16 times 3/2 would get us 24. So WX is 24. Okay, there are some check for understanding problems to do. What I want you to do is try to do these on your own. And then once you've attempted them, even if you don't think you have them all right, then after you've all attempted all of them, go and watch the video about how to do them and see what you got and what you needed a little bit more help with. All right, so go ahead and try these problems.